what is due is over on the board, 423, 424, 431, and 432. So 432 was assigned on Tuesday, but we're still finishing it, right? We still need to finish that lesson today, but 432 is your homework from Tuesday. Still kind of your homework today, but we're going to get into 433 as well. Alex?
Because of math testing today, what is our schedule looking like? I forget.
So same idea as yesterday, except now take out language arts and science. Okay, I was about to say, we have to be missing 2 classes.
Yeah, it's because those 2 are usually lumped together.
Okay. So Miss Howard and Miss Hassanin get a day off.
So
Well, that might be nice.
Yes. So, after this, you'll go to Connections, because Connections is blocked with me right now. Then you'll have, your social studies, global cultures. So, real quick, send somebody up to grab a coffee can with algebra tiles. Right, so send somebody up, just because I had a class right before yours and I didn't have a chance to grab a coffee can. They're all pretty much the same. I mean, they weren't the same type of coffee, but...
everything in it is the same.
Build this on your table. So go ahead and pull out algebra tiles to build this on our table.
Is one of you guys, Keegan or Raphael, grab one? You guys will both just sit.
What color is our x and x squared tiles? Those are the light blues, right? Those are the light blues. So we want an x squared, an x next to it, and a little 1, and a couple 1s over here. I don't know about illegal. So then chat with your neighbor, and on your graph paper, go ahead and write down P equals. Somebody thought they were funny. P equals, what do we use P to represent it? Perimeter. And we're going to talk about what the perimeter of that tile structure is. What is our perimeter? So chat with your neighbor real quick on your graph paper. We're going to write down P equals whatever the perimeter is.
Now I have coffee bean dust on me.
Oh no, you will survive, I promise.
Coffee beans.
That's probably not the worst thing that can happen, Raphael.
Coffee beans.
Yeah, I would agree.
You might need a full piece of graph paper, Raphael. Might be a little bit easier if you had a full piece of graph paper.
You said this was on a piece of paper?
Correct. This is not on, unless it's on the back. Nope, because that's practice work. That turns into practice work. Guys, remember, math lunch is open to anybody. If you need some time to work on your work, or you need some help, or you need a place just to work with somebody else, feel free to come to math lunch. Maybe your friend is not in the same AO as you, and you guys want to work on your homework together. So I need some help, and if you want to draw this on your graph paper, it definitely wouldn't hurt if you draw this tile structure on your graph paper, like Alex is doing. I need some help, so I should probably use cards. Yeah. Christian, help me out with an edge of this. You can pick what edge since your card's first. What can you give me a length of at least part of this?
I feel like I can take the hardest one, which I think might be here actually.
The one over here?
Yeah.
Okay. So Christian is flexing on us, right? He's saying, I'm going to pick the hardest one, and right over here. Okay, how long is that?
X minus 2.
Yeah, why?
Because the 2 squares block me.
Yeah, we're missing these 2 lengths down here. So that length right there would be x minus 2. Any questions on why our little purple length over here is x minus 2?
Because there's 2 squares.
Yeah, because these 2 squares are missing. We got to take those away. Question or just comment? Okay, sweet. So then the top here, Jana, we can actually start to like combine things if we want, or we don't have to. How long's the top?
X and then 1.
Yeah, we have an x here and a 1 there. Actually, I don't like writing in red because I often use red for negative. So let's do that in blue. So we've got a 1 here and an x here.
Can we do X plus 1?
You could write x plus 1 if you want to put them together, or you could write 1 plus x, right? What about the left side, Raphael? What about over here? How long would this length be?
That would probably be x minus 1.
Yeah, because we're missing that 1 at the bottom.
Yes, I know because of Ivan. Thank you, Ivan.
Thank you, Ivan.
That's nice.
Alex, what about, like, around here?
It would just be 3 orange.
Yeah, 3 1s. So you could either say 3, or you could say 3 1s. I'm going to switch back to purple since I'm so far away from my other purple. Wait, what about the bottom of the x?
1.
Also 1.
And then under the X2, it would be just X.
Ah, this length across the bottom. I guess I'll switch to orange. This is x, because we know the edge of x squared tiles is x. And then, running out of colors, we got a 1, and a 1, and a 1, and a 1. So now we need to clean this up and combine our like terms. I'm going to write all of this down first, though. So I'm going to start with my purple 1s and just kind of take a walk around the shape. 1, 2, 3, 4. So I'm going to say 4 for here, plus x minus 1, plus, and actually Jana brought up, I can call this x plus 1, right? So x plus 1, plus x minus 2. Do I need to group these in parentheses, or are those parentheses, like, can I do x minus 1? Not if I don't know what x is. So actually, these parentheses aren't really necessary. I don't need to put parentheses around these things. 1, 2, 3, 4. Technically what?
You're technically minusing the 1 from the full number.
Yeah, we're minusing the 1s from whatever the x turns into. And I still need my orange x. Now guys, this is actually like, I could honestly just look at what I've written up here since I labeled all of this. How many x's do we have? Just anybody.
4.
4! And if I look here, 1, 2, 3, 4. So really, I got 4 x's. Plus, how many 1s do I have? 9. But, yeah, 9, but I've got minus 2 and minus 1 more.
So it'd be 6.
So really,
X plus
6. So when we combine all those like terms, we get 4x plus 6. Does that make sense?
Yeah.
Thank you for actually saying yes. Most of the time you guys just stare at me. So guys, remember, x, like we talked about over here, are flexible. But can be anything. Guys, x could be like a foot, right? This is about a foot. X might be a foot. X could be like a meter, right? X could even be like whatever length this is. This is like 6 feet. Like x could be anything, right? So what we're now going to play with is what about different x's? So hold up. With your partner, we need to get 4 different answers now. What about x being 5? What would the perimeter be? What about when x is 3? What about if x was 2? And what about if x was 1?
Whoa.
So solve these all out on your paper so you can label it A, B, C, D if you want. What about when x is 5? When it's 3? When it's 2? When it's 1? And like, imagine what this would look like as x changes size. Like, what would this structure look like as x changes?
Are we only doing perimeter?
Only perimeter. Because perimeter is tougher. Perimeter is more difficult in this unit.
I think what we should do is, we should get like a Nerf gun full of bullets, and then
What?
we should get, if someone like passes, then you get the like Nerf gun.
So
That
can
sounds-
you play out in your head how a teacher shooting things at students probably is a good idea?
I mean, I saw Clark
You're wrong.
teach you to do it.
That might be a questionable decision on their part.
Yeah.
So-
wouldn't do it.
This, when we talk about this in math, replacing things, and now we don't really say this as much because we say guest teacher, but this is what we call substitution. Okay, so if somebody ever tells you, like, do a substitution, what that means is we're going to replace, based off what they tell us, for the x, right? So if x equals 5, now I'm going to say 4 times 5 plus 6, right? Because instead of x, we substitute it.
Which means that it's now actually 26.
Which means in A, if x was 5, our perimeter would be 26, and we could call that units, because they tell us units up here.
That would be like
Hold on, slow down.
my brain.
Ivan's trying to flex even without his math binder. He's pretty darn smart. So if x is 3, we can do the same thing, except substitute 3 in. That's great. There we go. So now perimeter would equal 4 times 3 plus 6,
18.
which Ivan wants to tell us equals 18.
C.
You like trying to prove me wrong or something? That you're like, I don't need my binder. But tomorrow, homework's due. So binder's going to be important tomorrow.
Wait,
Uh,
tomorrow's Friday?
Yeah.
I
Oh my
sure
God.
hope so. I sure hope so.
Bro, what?
Guys, we all need winter break like a fish needs water.
Yes,
Like,
we do.
I'm telling you, I can't wait for break.
How's
Me
it?
either.
Also, because I get to see my sister. She's coming into town.
I get to
Hey!
see my
I get to see my family
I get to
members
see
from
my
house.
family.
Ivan, what's perimeter?
That was 14.
I almost got you. I almost got you. So this becomes...
Oh no.
Okay,
Oh my God.
there are ghosts in this building. I'm convinced.
That's what was happening then.
So 8 plus 6 is what, Ivan?
14.
14. And if x is 1,
That means it's gonna be 10.
4 times 1 plus 6. All right, Ivan.
Bro, wait,
Good
what?
work.
Good job, Ivan.
See, and this is what I was talking about with Pedigree yesterday, though. You're like top of the class in my room, and apparently whatever you're doing in her room is different. So we had this on our paper, right? We built this. But guys, as x was like 3, did you imagine like, okay, so x is probably too big here. X would shrink down a tiny bit if x was 3. If x was 5 here, actually those purple tiles that we have would maybe look better if they try to make x 5. Like, if this is 2 and I made x 5, like, that's probably pretty close to what it would look like. But then I would need to change this tile too. But guys, imagine if the length of x became 1. What would 1 squared be? 1. What would the x tile be? What? Guys, this would literally, like, the x tile would get replaced with a 1. The x squared tile would get replaced with a... The structure would now look like this. Which actually... 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11... Wait a minute. I thought we said the perimeter was 10, but if I actually build this and count it, I just kind of broke math. Like, according to our equation, we said perimeter would be 10, but if I build this and so guys, there are like certain times where like this broke our problem. Literally, making x1, we shrunk x down so far, we kind of broke math. And that, like, that does happen.
When you're using one in an equation and you're using it to multiply something, it won't change the answer, but when you're using one as like a solid shape.
What?
Yeah, like, physically, it's different than like, we did it mathematically. Like, what Margot's saying is, like, we substituted it and we did the multiplication. That's fine. We did it. But when we actually think about what it will look like, well, now we broke it. And guys, I'm not saying we did it wrong. Like, do not think I'm saying we did it wrong. This is what was supposed to happen. We done broke math. Now, I forget who it was. It might have been somebody in this class when we were talking about dividing by 0.
Oh, yeah.
Guys, dividing by 0 breaks math.
Yeah.
Because, okay, let's talk about this. If we win the homework competition, right? If we win the homework competition, and let's say I buy ice cream sandwiches for everybody, right? I have, like, a bucket of ice cream sandwiches. Just imagine with me. I've got a bucket of ice cream sandwiches,
That's not
right? If you all win, there are 33 of you, right? So I'll take the ice cream sandwiches. Now, we'll involve Miss Martin and myself.
I was gonna say.
So we'll take the ice cream sandwiches, divide by 35. Now, if you don't win, well, let's say nobody wins and I keep all the ice cream.
How could you?
If I keep all the ice cream, what am I dividing by?
0.
No.
Well, 1.
1, right? Because I'm 1.
Where are you?
If I take the ice cream and divide it by 0, nobody exists.
Wait.
There's nobody to eat the ice cream.
I thought since that before.
And what, Margot?
Yeah, I was like, it's here.
What? So, hold on.
It used to be-
Margot, what are you quoting?
So it used to be that when you asked Siri what is 0 divided by 0, she would go, imagine that you had a like
Cookie
a-
Monster, actually. She was talking about Cookie
Yeah,
Monster.
Imagine you had a jar of cookies and you tried to divide it by 0. It won't happen. It's impossible. And Cookie Monster is sad because he had no.
Yeah,
because he had
Cookie
no
Monster's
cookies,
sad.
And you are sad because you have no friends.
Yeah.
It's like trying to divide between 0 friends.
Siri, like, subtly would throw shade at you for having no. But guys, if you think about like, I've got my thing of cookies and I divide it by like nobody exists. That breaks math.
Wait, Mr. Lesson.
So there are ways that we break math. All right, refocus. I got people doodling.
Oh man, I want to ask.
Now, not only can math be broken, but math can get used to make people think that you're magic. Like, not kidding. So, think of any number. Just hang on for a second. Think of any number. Write it down on your paper. Now, the bigger, like, the more complicated number you use, the tougher this might be.
Let's go.
Think of any number.
2.
Write it down on your.
Think of any number.
10 is my.
Uh-oh, he turned the board off.
What should we do to
This is
With that number, like, take that number and triple it.
I'm gonna need my calculator.
Pick the big one.
I'm just gonna lower this so it's easier.
Oh yeah, you might need a calculator too.
Add 1 to it,
Wait, I'm not even.
and then multiply by 2.
Add 1 and multiply by 2. You said?
Yeah, add 1 and multiply by 2.
Now, here's where some of you might regret what you did. What if we try to build this with algebra tiles?
Oh, no.
Uh-oh. So, wait. What would our number... If we say, like, a random number, what could we use for a random number?
50.
Well,
Guys,
like,
make it low.
for any, that would work for any of you.
3.
X. Right? Because you all chose different numbers, and I don't know what they are. So this any number, let's call that X. So guys, on your paper, go ahead and write down, like, X real quick. How would we triple X?
3x.
3X, right? So 3X. How would we add 1?
Plus 1.
Plus 1. Careful. So guys, if you said 4X, it's not true. If we tripled X and now want to add 1 to it, we literally add 1, not 1X, just 1. Then, how do I multiply what I have now by 2? Christian?
You put the parentheses
Ah,
and put 2 in front of it.
Parentheses.
Yes.
Now, guys, this brings up a really important thing we haven't learned yet. The distributive property, which is in your notes. Like, it's in your math notes. It's been on your homework, because your homework likes to, like, show you things before we actually learn it. Hey, Margo, I feel like as if you are distracted. So, on your graph paper, what I need you to have written is 2 parentheses 3x plus 1. Now, if you want to build it, you can go ahead and build it. So, if you want to build it, that's up to you. So, I need 3x's, 3x's, because x's, right? Not x squareds, x's. And an extra 1. Now, wait a minute. Christian, I don't know if you can help me out again because you helped me last time. What would I do with my tiles to show, like, times 2?
You add.
Can anyone tell me how I can, like, physically double, like, multiply by 2, Misk?
Double it.
What do you mean?
Like get 3 more x.
Oh, like build it again?
Yeah.
Okay, so 3 more x's and 1. So guys, what I have now is 2 sets of 3x plus 1. Raphael, you with me? Look like we're doing a big stretch over there. So how many x's do we actually have? 6. How many 1s do we actually have? 2 on your graph paper. Guys, I'm telling you, if you don't do what I'm about to show you, you're gonna make a mistake eventually. I, like, promise. Because I already caught accelerated 7 people, like the compressed class. They're trying to skip over steps and they're making mistakes. So look up here. The trick to this is drawing arrows. Now you could either draw them on top, or I kind of think it makes a bit more sense to draw them down here. But these arrows remind me I need to distribute. You could write this on your paper because it will help you remember. I need to distribute, which means like give to each. I'm hoping I'm going to need to distribute ice cream sandwiches or something, right? I hope I'm going to need to give to each of you, right? To distribute. So what was 2 times 3x? How many x's did we end up with? 6 x's. And what was 2 times the 1?
2.
Ghost. I'm telling you.
Mine doesn't do that, so it must be on this side of the building.
If you want to write your work out, what we did was 2 times 3x, and we also did 2 times 1. Jared? Sure. Maybe it's the ghost of, well, like, Jared passed. Like, you know Jared from Subway? He lost, like, a person worth of weight. Like, he literally lost so much weight, I think he said, like, he lost a person worth of weight, which is kind of crazy to think about. Who? Is it? For real?
Yeah, Dawson now.
All right, so real quick, let's try 4 times 2x plus 3. So, like, if I go to build, like, guys, I'm not saying you should. If I go to build this, I'd have 2x plus 3, but I need to build this 4 times. It's probably just easier to do the math on our paper. So maybe we should just do the math on our paper. So 4, oh, that's bright green. I don't want that quite yet. 4 times 2x plus 3. What are we going to draw?
Arrows.
Arrows.
Ayo, 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 ayo.
Not like your archery unit. Arrows. Those are dangerous. So what we're doing... Ghost!
Dawson!
It's messing with you today.
Have you seen June's archery skills?
No, we're not.
4
Turn on
times
the lights.
2x
Ghost, take lights.
and 4 times 3. What are we going to get?
8. 8x plus 12.
8x plus, yeah, 12. Now wait a minute. If this works going forward to like figure out how many I have in total, could it work going backwards to break things up into groups? You betcha. So what if we had 12x plus 18? So, I'm spending too much time thinking about colors. If I think about having 12 X's on my paper, you don't have to get them out because that's a lot of tiles. And 18, what could, 12 and 18, I feel like they get along in a certain way.
4 and 6. No. 20x. 6 and 3. Oh, no. I mean, that's 6 times 2 and 6 times 2.
6. Wait.
So,
2 times 3, or 2 and 3. So 6 times 2 is 12, and 6 times 3 is
12 and 18 are both multiples of 6
And 3.
and 3, but we're going to pick the bigger option, right? So since they're both multiples of 6, what we're going to do here, I want some more screen, is we're going to say, okay, if we broke them into 6 groups, and so you could, on your paper, you could show, okay, we're going to divide everything by 6. That's how this 6 comes out here. What's 12 divided by 6? 2, and we got to bring the x along. What's 18 divided by 6? 3. O-M. This is what we call factoring. So when your homework, and if you're not paying attention, if you're not writing things down, guess who's not going to be sad when you are struggling?
You.
This is called factoring. So if somebody asks you your homework, cough, cough, to factor an expression, that's what this is. This is factoring. So try that with your partner with, what if we had 10x plus 15? What if we had 10 plus 15x? How do those numbers get along with each other? Talk with your partner, write it down, factor that. 10 plus 15.
Well, Ivan, why don't you help Miss and talk to Misk about it and see if you guys agree?
Probably use cards because you guys are starting to like compete with each other or like try to.
We're always competing.
Well, that's funny.
Is it Ivan?
All right, Ivan, you want to flex your math skills?
It's 5.
It's, but what do you mean? It's 5.
So it's like you have to. It's like a time. You have the time. It's like 5 times.
So then we'll write.
And 3.
Yeah, 5
3x,
parentheses. 2, boom. We got to make sure we bring the x along. So Ivan almost forgot it, but he caught himself. If we factor out a 5, what's 10 divided by 5? 2. What's 15x divided by 5? 3x. Questions? Ivan's over here killing it.
What's he killing?
Well, that's like a kid expression, right? Like when you're killing it, you're like doing really well.
It was a joke. It was a joke.
All right. What about 21x plus 7? How could those get along with each other? What could we do with Addie?
3.
We say
3
more.
is the factor.
7 can divide by 3.
I mean, no.
I know why your brain is saying 3.
Yes, I'm done.
You're jumping to the answer. You're not dumb. You're jumping to the answer. What could we divide these both by? 7. But Addie's brain was jumping straight to the answer because after we divide by 7, what happens, Addie? Why are you not changing colors like I want?
It's the ghost.
Yeah.
Ghost.
So 7 times, well, 21x divided, oh, Addie ran away now. That's where your brain got the 3. What's 7 divided by 7? 1. Baboon. Questions? That's balloon. Okay. Oh, baboon. I thought you were talking about Jungle Book. Now, here's the problem. We are just about out of time. We got like 6 minutes left. I'm going to start 433, and technically it's today's homework, but like we're going to need to get to it tomorrow, like finish it. That's why up there it says 433 finish. Technically, I don't know. You can tell yourself there's homework today, tomorrow, what. I don't care when you tell yourself the homework is assigned. It won't be due till next Friday, right? 433 won't be due till next Friday. 432 is due tomorrow. So let's go ahead and jump into 433, however far we can get with it. Anyone want to read? Jana, you want to go ahead and read these? Well, there's a lot. Do you want to read all of this? So guys, read along with Jana. Don't just listen. Like, look up at the board, read along with what Jana's reading.
In this lesson, you will continue to explore various ways to express simpler by finding parts of them that make zero. Zero is a relative newcomer to the number system. Its first appearance on the placeholder around 400 BC in Babylon.
Wait a minute. Guys, especially if you're not listening. What? Zero's a newcomer. Zero didn't exist? This is such a weird... Zero didn't exist until 400 BC. Literally, before then, like, what do we use zero for? You don't count with it. Right? If I'm counting students, I go 1, 2, like, I don't start at 0. Zero's nothing. So guys, literally zero didn't exist until about 2,500 years ago, which is kind of recently, if you think about how long humans have been around.
How do you feel calling your students nothing?
Oh, I know, right? So zero made that little sign over there for me, and that's why I hung it up now that we're going to be talking about zero. But zero is actually really important in math. So that's a funny thing. Zero means nothing, but it's actually really important. So Jana, go ahead and keep going.
The ancient Greeks philosophized about whether zero was even a number. How can nothing be something? East Indian mathematicians are generally recognized as the first simple quantity zero as a numeral and a number in its own right around 600 AD.
So guys, in India, they didn't actually like formalize the idea of zero until 600 AD. Guys, that's pretty recently. That's like 1,500 years ago, right? Like, that's not that long ago. Go ahead and continue, Jana.
Zero now holds an important place in mathematics, both as a numeral representing the absence of quantity and as placeholder. Did you know there is no year zero in the
I hope you all know this because somebody taught it to you.
That's paragraph.
Go ahead, Jana.
In the Gregorian calendar, our current calendar, 365 days in it. Until the creation of zero, the number systems began.
So guys, think about it. When we like went from BC to AD, like not every culture even understood what zero was. There was no year zero, right? They went straight from BC to AD.
Wait,
There was no year zero. Yeah.
what if writers that had known about zero, like wrote down a year and it was like it had a zero in what would they do?
So that brings up another really good point. So the year that we're in right now, what year is it? 2022. This zero is really important because, guys, if I write this as 222, is that the same? No! Like, that zero is really, really important. Because otherwise, you're going to time travel 1,800 years ago, and I don't know if we want to go back there. Things were even more broken then than they are now. Margo?
Is it 21st century? Like, but it's 20.
Well, like, whether I agree or disagree with you, like, we can't change what's already happened, right? Like, and, like, that, you're fine to have that opinion, but, like, we can't change what's already happened, right?
I know.
So, yeah, I mean, so Margo's arguing she thinks it would make more sense to have a year zero, like, as, I don't know, as, like, a placeholder, as a like, switch from AD to BC, but would it be BC or AD?
It'd be BD, it would be BD. Like BD.
I don't know. Alright, so let's talk about this. Actually, how much time do we have? Now let's pack up. We'll do this tomorrow. We'll keep talking about zero. We'll get all weird talking about zero. Don't get all weird like that? Okay. Ivan, aren't I like just normally weird? Thank you. I'm already weird enough.
Aw, man.
Sir.
Speaking of time travel,
Aw, man.
so what if